Hello again, and welcome to another Unity and FMOD tutorial. Before we jump into this tutorial, I just want to quickly apologise for not uploading many videos recently, but I'm hoping this one will make up for that because it's quite exciting what we're doing. At least I think so anyway. So today we're going to be using, or looking at audio occlusion within FMOD and Unity. So for those of you who don't know what occlusion is, it's basically a way of altering something depending on obstructions or things that are either in the way or not in the way. For example, I know occlusion culling is a thing within game development where depending on what the player actually sees, that's the only thing that gets loaded into the game, which helps, save on memory and, CPU and all that stuff. Light occlusion is another thing, so it might be a way of determining whether or not shadows are visible or not. But we're going to be using audio occlusion, and what audio occlusion is basically a way of changing parameters or changing effects of an audio depending on whether something is obstructing the player or the listener from the audio source. I've set up a quick little scene in Unity to demonstrate this. Let's quickly jump into that and show you what it is. So if we look on the left there, the square box is the audio source. That little capsule moving around is me, the player, and if you notice there's a red line that's shooting from the box and hitting that wall. And what that is a raycast, or rather a line cast, which is how we determine whether or not the player is in front of the audio source or behind an obstacle, which I'll talk about a bit more in a bit. So yeah, as you can see, that line hits the wall and then stops. And because of this, it's basically saying, okay, there's a wall in the way, so we want to affect the volume of the audio as well as the filter, so we want to get rid of some frequencies so it's not as clear. If I walk around the wall, however, you'll notice that the audio becomes a lot more clearer, louder, and then that red line turns to blue, and instead of hitting the wall, it reaches all the way to our player. So I'm going to walk around a bit and just demonstrate this a bit further. So I'll walk over here. Go. So that's basically all there is to audio occlusion. Obviously there's more things you can do with it, but for this tutorial I'm just going to show you how to set this up within your game. So the first thing I'm going to do is jump into FMOD. Now what I've done in FMOD, it's not very complicated. There's a lot of stuff that we've done before, so I won't talk about it too much, but I'll quickly go over what I have done. I've basically created a 3D event in FMOD over here. I've added some music from the audio bin. And I've set up two parameters, a volume parameter and a low pass filter parameter. The volume parameter ranges from 0 to 1, and it basically says when the parameter's at 0 we won't hear anything, when it's at 1 we will. Okay. Same thing for the low pass filter parameter, except I've set it from 10 to 22,000, or rather I've set it from 10 to 22,000 up here. And the reason why I've done this is so that when we see it in Unity, we can actually determine exactly what frequency we want the filter to cut off at, which again I'll explain a bit more in a bit. What else? I've also, if I click on the parameter, I've also set up the seek speed, which basically prevents the parameter from snapping from one value to another. I've basically set them both up so that they will change within half a second. Okay. And I think that's all there really is to FMOD. I'm just quickly going over in my head if there's anything else. No, that's not really. So let's have a listen to the music. Let's just change the filter a bit. So that's what we're going to be working with. By the way, if you're interested, this is music that I've composed myself. If you're interested in checking some of that out, you can just go to my website, which I'll link in the tutorial. But enough about that. So that's, yeah, I'm pretty sure that's all there is in FMOD. Just remember our event is called Occlusion Test, because obviously we're going to need to find that later. Save that, Command S, click build, we're good to go. So let's jump back into Unity. So here's our script here, our audio occlusion. This is what performs the magic, but I'm actually going to create a new one and try and build it from scratch to show you a bit better. So let's turn that off, come over to project, and we'll create a new script. We'll call this Occlusion tutorial. Hopefully I spelled that right, but if I don't, oh well, doesn't matter. Cool. So let's come over to our sound, quickly throw that on before we forget. because the script class can't be found. Why is that? Oh, is it just, did I just do it too soon? Hold on, let's double check. See if it's done. Oh, whoops, come over to Unity. There we go, okay, cool. So there we go, we got the script up. Cool, so let's jump into Model Develop, messing around with that. So, first thing I'm going to want to do, get rid of all that. I'm going to want to add our variables. So I'm just going to quickly, for the sake of time, I'm just going to quickly copy and paste the variables from our old script into here. Cool. Give that a bit of space. Cool. So I'll quickly run you through what I've done here. So first thing, I've just used headers here, which you could just type header in square brackets and then quote what you want to call the header. Which we'll see in a bit. It's really good for organising, and I've only just found out you could do this, so I'm I'm using it a bit too much in most of my scripts, but there you go, that's something you could do. Like we've done in the past, I've used FMOD Unity.event reference, then used a public string to create a little bar where we can find our event in FMOD, set up some instances, so 2 parameter instances to find our parameters, and an event instance to find the event, and giving them all names. This transform variable, this is what we're going to use to find the studio listener. If I quickly jump back into Unity, where's our player? Come over to our player. You'll notice I've got this studio listener script attached. Now this is a component that comes with FMOD, and it works just like Unity's, I think, what's Unity's called? Oh, audio listener, so it's right there. So it works the same way as that. It basically determines where the player is going to be hearing all the audio from. So obviously, in a first-person game like this, I've attached it to the player, so they hear all the audio from a first-person perspective. Now, what we want to do in our script is actually locate this, and depending on the location of this listener, that's going to depend on where our raycast is shooting from, which again, we'll explain a bit more in a bit. So, some more variables here. I've set up another header. I've also set up ranges for our volume value and our low-pass filter cutoff value. So we're going to use these to basically determine in Unity how we want to adjust our volume and our low pass filter. The range is quite good because it actually it adds a slider in Unity. So as opposed to just typing in a number, we can just use a slider to kind of tweak where we want our values to be. So last variable is a layer mask variable, and this is basically what Unity uses to determine what you want to obstruct any occlusion with. If I quickly jump back into Unity, we'll jump into the old one. Where's our sound? Where's the old script? So here's what happens when you use the layer mask, and you get a few options basically. I've just left this on default, so basically anything with a collider will break our raycast, which is all we really want for this tutorial. But if there's a few more options which you can mess with if you like. So that's all the variables you need. So let's jump into our first function. And again, I'm just going to quickly copy and paste it in. Save us a hell of a lot of time. So first function is void awake. So this is going to call some stuff before the game even starts, before the first frame's called. I'm going to play the audio on the first frame, so it makes sense to just call some stuff before that even happens. So first thing I've done is with this variable, SL location, I've used this line to find the what's it called? The studio listener component, which I explained earlier, which we need to determine where our player is listening from. Notice how the studio listener is in red, however. Currently, this is giving us an error saying it can't find it. Now, the reason why it can't find it is because that's an FMOD component. So for the script to recognize it, we need to add this line up top. There we go. We need to use using FMOD Unity, and now you should notice that the studio listener has turned blue, so now it recognizes this. So this basically says that we're going to be using FMOD components as well as Unity ones. Okay. Next, stuff we've done before. The event instance I've connected to our select audio string. Easy enough. That's going to, obviously help us to get the audio playing. Parameters again. We've called parameters. We found the volume and low pass filter parameter in FMOD. Make sure you get the names right, by the way, otherwise that won't work. And we've just sent them out to our parameter instances there. Cool. So stuff we've done before. Again, I'm pretty sure we did this in the footsteps tutorial, so I'll probably throw a link in the description or on the screen somewhere for that if you want to find more information about that. So next function is the start function. So I'm going to quickly copy and paste that in. There we go. So void start, this is going to be called on the first frame. Now all this is doing here is using FMOD playback state to determine if the audio is being played or not, which is important for using 3D audio, which is what we're doing. Again, this is stuff I've covered before, so I'm going to throw another link in the description or on the screen for you to see. But all you need to know is we're saying on the first frame, we're going to tell the audio to start playing. Simple enough. So, next is the update function, which is going to contain a lot of the meat of this script and how this actually works. So, let's come over here. Oh, actually, I think I'm missing something. There we go. So let's paste that in. So, void update. So first line, again, this is used for using 3D audio within FMOD. So check out the tutorial for that. So I'm not going to talk about that too much. Right, this is where we're going to be actually creating our raycast. So the first thing we're going to do is use raycast hit and give it a name, which I've called hit. Now this is going to be used to determine what information we get from the line when it's fired out, okay? Then we're going to want to type in physics.linecast. So obviously, like I said earlier, or did I mention? I can't remember if I said it earlier. If I didn't, the difference between a raycast and a linecast. Basically, a raycast is a line that's fired out within game that's invisible to the player, and it's used to determine if there's any information between that player or an object it hits, or if it's hitting an object at all, you know. The difference between a raycast and a linecast is that a linecast actually has a location or an end location. So it's used to determine if there's anything in between the start and the end location, whereas a raycast doesn't have an end location, it can go on forever essentially. It's used to see if the player is facing any objects at all. So obviously, because we have an audio source of player that's never going to change, we want to use a linecast. We know the start and the end point, so we use linecast instead of raycast. And then we use some brackets and we give it 4 information, 1, 2, 3, 4. First we give it the start location, which is basically the transform position of whatever this script is attached to. So if I quickly jump back into Unity, we attached it to our sound game object, and we're going to be using the transform position to find out where that's starting from. Then we're going to use the studio listener location, which we set up earlier. So again, if I jump back into Unity, that's going to find our player, find the studio listener. Okay, so studio listener's attached to the player. We're going to use the transform position information from that game object then. Okay. Next, we're going to use out hit, and this basically is using this variable here, so it determines the information that the line actually hits, so whether or not we're going to use that to say whether or not it's hitting the player or not. And then lastly, the occlusion layer, which is the layer mask here. So this allows us to determine what we're actually, you know, what's going to break the line, if anything at all. Okay, so that's all you need essentially to fire the line. Just those two lines of script there. But I've also added a few lines of script here, which I'll explain now, which actually allows us to see it within the scene view of the game. So what we're saying here is if the line hits a game object with the name player, then we want something to happen, okay? The first thing I've done is use two custom created scripts, custom created functions, which I'm going to add in a bit. That's why they'll appear in red, because I haven't added them yet. But I've also added this line here, debug.drawLine, which allows us to determine, well, allows us, like I said, allows us to see the line. So again, we have to put the start position. So it's the transform of this, whatever the script is attached to. The end position, so the location of the studio listener. And then we can also choose the color. So as you see here, if the line hits the player, I've told it to go blue. So then we can go, okay, cool. The line's hitting the player. They can hear the audio fine. But where on the else statement, I've changed it to red. So if it doesn't hit the player, if it's hitting something else, if something's obstructing the line, then it changes to red so we know, okay, it's not reached the player. Which, by the way, in case I haven't explained it before, you can use an if statement to determine something and then an else statement to determine the opposite, essentially. So if the line is hitting the player, this happens. Else, if it's not, this happens, okay? So hopefully I explained that all correctly. Let's add our last two functions in here now. So these are the two custom functions that I've added to the if statement, not occluded and occluded. So if the line hits the player, I want the not occluded function to activate. So this is the not occluded function here. And what it's doing is it's going to set the value of our volume parameter and our low pass filter parameter to 1 and 22,000 respectively. Okay, so basically they're gonna just play normally, you know, they're not gonna change. However, if it doesn't hit the player and it becomes occluded, we're going to perform the occluded function, which does the opposite. Instead, we're going to say volume parameter is set to the volume value, which is what we determined up here, or rather what we're going to determine in Unity when we see these public floats. Okay, and again, we've done that for the low pass filter. So in Unity, we're going to be able to adjust those sliders, say what we want these values to equal, excuse me, and then that's going to change the parameters. And I think that is all there is to it. So let's quickly save that, jump back into Unity, let's let it compile and make sure there's no errors. Hopefully there isn't. I think that's everything there is to do. Cool, doesn't look like doesn't look like there is. Oh, maybe there is. No, okay, good, we're good. So let's go on our sound, let's find our event. We're going to use the occlusion test. I'm going to let's leave these values for now. I'm going to leave the occlusion layer as default, and let's play. That's off. Yeah, that's off. Okay, so let's play it. We should get the line, hopefully. Yep, there's our red line. If I come around here, there's our blue line. Cool. So if we want, if I click escape, we can adjust these values on our slider while the game's running. So let's mess around with the volume. How loud do I want it when it's... Maybe about there, and then a low cutoff. That's way too high. Maybe about there. About there. That feels right to me personally. So now we can test that out. Go back into the game and see if we like that change or not. Obviously, because I've done it when the game's running, they're going to change back to what they were originally. So just remember the values you've set, and then just change it back. That's what you've got to do. Cool. One final thing I'm going to go over is that this actually works for binaural audio as well. So again, I'm going to throw a link in the description or on the screen for that tutorial. But if you remember, we've messed around with binaural audio in the past, and we could do the same thing with occlusion. So if I hit play, we should get our old binaural sound from the last tutorial. And it gets included the same. So if I go up to this audio and turn my head, if you're wearing headphones, you should hear it circle around your head. And if I come around here, in fact, let's make it a little bit clearer, because we can't quite hear it. There we go, about there. In fact, we'll turn the volume all the way up for the sake of this tutorial. We'll turn the volume up, leave the filter about there. So come back to the game, we can still hear it circle around our head, even when it's being occluded. So that's really cool to know. If I quickly jump into FMOD and look at our old binaural audio event, you'll notice what I've done, if I come over to timeline, is I've added this new, I forget the name of this actually, let me quickly double check, add audio track, what's it called? Oh, event sound, okay, so I've added a new event sound. Previously, we had all our audio just laid out in the event, 1, 2, 3, 4, don't do that anymore, delete that. We had all 8 audio tracks laid out in the event, which worked at the time because we were adjusting the direction parameter for each one differently. However, because we want to adjust the volume and the low pass filter for all of them, we can use this to essentially change them all. If I double click, we can see them all as we left them last time. There we are, there's all our audio tracks. We can change them all without individually having to go into the parameter and set the exact same settings for all of them, which is really good. As you can see, we've got a little navigation bar to jump back up here, and I've done the same. I've set the volume and the low pass filter the exact same way. Okay, and it just allows us to globally change all the audio tracks within the event, essentially. And all we had to do was, if I quickly add another audio track, say this had our audio track in last time, all we had to do was click copy, double click, and click paste, and we could add it back in here. Okay. So, that's something to bear in mind. Maybe if you want to organise your audio events a bit better, you can change the parameters of all of them in the same way without having to, manually put the same, settings up constantly. Other than that, though, the parameters are exactly the same as we set them in the occlusion test. So it works the same way, essentially. And I think that's all there is to it. So, yeah. So there you go. You can use binaural audio as well as just 3D audio to create this effect. So that's all there is to it. Let me know if you enjoyed. Let me know if there's anything else you'd like to see. I'm planning on making another audio video about using line and raycast. I'm thinking of maybe talking about how we use interactive audio, or interactive music rather, in FMOD, because that's something we haven't touched yet, whilst using the Ray and the line cast to determine how we want that to change. But if there's anything else in particular you want me to talk about, please let me know in the comments, because it's great to get feedback from you guys. I've had a bit more feedback recently, so that's been a massive help. And yeah, that's all there is to it for this video. So I've been Henry Scott, and thanks again for watching.